Let's compare now this present interglacial with the one immediately previous to this. It's about 130,000 years ago. And you'll notice it's remarkable how the slopes, the upward slopes, are pretty consistent. The top is not as consistent. Ours is flat. The previous one had a peak and a downslope. And of course, this is what happened in the past. And we want to know what's going to happen in our future. This was the future of the past interglacial, of the previous interglacial, and we want to know where we're going from this point. So here we are comparing the previous and the past interglacials, and they match. Incidentally, you have to slide the previous one on top of the present one. And where do you match it? Well, I match this slope right here. I match this slope. When Professor Roper did it, he matched this slope. But I think for various reasons it's reasonable to match this slope at about 12,000 years. So let's look at the next picture. And this is very complicated, so we're not going to try to extract much information from it. But these are the 5 interglacials. The present one, which is 0. The one about 100,000, 130,000 years ago, it's the red curve. The one roughly 200,000 years ago is the blue curve. It's the thin one. The one 3,000 years ago is the green curve. It's right in here on top of the red curve, so it's pretty hard to distinguish. And the one 400,000 years ago is the red curve, which we are going to let's simplify this picture by removing the red curve and the blue curve and just consider 3 interglacials. One of the reasons is that they seem to have a different character, number 2 and number 4. But here is 3 interglacials. The present one, the one 130,000 years ago, that's -1. As I recall, that's the this curve, and interglacial -3, which is 300,000 years ago, and that's the green curve. The red and the green curves, I think, they have a remarkable similarity. They both have this peak. Neither of them have this 2,000-year hiatus that we had in the our present interglacial. And I'll just point out that I think that because of this reduction of heat for 2,000 years, we didn't overshoot. This is what I consider an overshoot, and then we're coming off of the overshoot. This actually prevented the overshoot from happening, this period, and flattened out the curve, and I think that's why it's flat. The interesting thing you'll see is that this is the present day. There's this line right here, and we're just about on track with the downward trend. There's no doubt that in the next 10,000 years, things are going to go downhill, and a significant amount. 6 degrees here is the 6 degrees centigrade, so roughly 10 degrees Fahrenheit, in my opinion. So judging from what's happened in the past, as the Vermonter said, it always has. Well, it hasn't always, but twice in the past we've followed this curve. To my mind, it's remarkable. Within a few tenths of a degree, we've had repeated the history. And as Muller's book points out, it's almost got to be astronomical if it's that precise. So finally, we'll just comment again that all 3 interglacial temperatures match very well, and that today's temperature is on track with previous interglacials, and it's falling from here. The previous interglacials fell from here on in. course, they fell from here, but that was because they had this peak. We don't have the peak because of this interruption, so we didn't. So we don't have the fall from the peak. So in general, our pedestal has been pretty constant, but there's nothing that I know of, unless carbon dioxide can prevent it. That's nothing. There's nothing I know of that will keep us from falling another 6 degrees centigrade. So I believe that we're near the end of the talk. My conclusions are that that insulation is the primary driver. It started dropping about 12,000 years ago, and if CO2 is prolonging the peak of temperature we're on, we are probably getting near the end of that. As far as the future goes, for the next 60,000 years, we're going to have a lower insulation than we've had at any similar length of time in the past. There's no doubt in my mind we're heading for an ice age, which is going to be 6 degrees, and as it develops, probably goes down to 10 degrees, just like has happened 4 times in the past 500,000 years. So in the future, we need to improve the mathematical models. In my opinion, the mathematical models that are being used should be make sure that they predict what's happened in the past. That's what I used to do when I worked with models, was make sure that they predicted the past before I used them to predict the future. The nonlinearities are not well understood in the time constant of glacier formation and of forestation and deforestation. All those things have to be understood. They change the albedo. They change the reflection, what percentage of the heat is reflected on that first pass, and accelerate. They accelerate warming and they decelerate cooling, and so you get a sawtooth curve. Well, all that has to be understood better. We ought to not spend money. In my opinion, we shouldn't. We should spend money moving our agriculture south. Now, of course, 5,000 years in the future is a long time to be planning ahead, but we're going to have farms in the Sahara Desert, where they used to be when we had ice ages, and probably in our southwest. One of the wildest things that's going to happen, of course, is that the sea level during an ice age is going to drop. And it's not a minor amount. It drops 300 feet. As far as I know, the present continental shelf is about at this depth. And that was the old ice age sea level. So, in Muller's book, he has this picture. He said he saw it when he was a boy, this issue of Amazing Stories magazine, and it showed the glaciers coming down and wiping out the skyscrapers. And that may be our future. Thank you.